Next will be Kelvin Wang discussing crack definitions. Kelvin Wang is Regents Professor of Civil and Environmental Engineering at Oklahoma State University. His research has focused on the problem of automating surveys of pavement distresses, and is a leader in automated sensor technology and software solution. He is active and past president in the Transportation and Development Institute of ASCE.
I really appreciate the opportunity to talk to at the national conference. The title of the presentation is called Cracking Definitions. My name is Kelvin Wang. I'm a professor from Oklahoma State. I just recently received the honor of being elected as a distinguished member of ASCE, so I'd like to share this news first time in public with this important conference. We are going to talk about some of the findings from an NCHRP report 01-57A. There's an A after the number. That's because actually the project was started without the A, and then they had to restart the project with us. So that's essentially the second iteration without any outcome from the first iteration. I'm going to talk about developing a standard definition set for pavement cracking. And the motivation to do this project, of course, came from the problem statement that was submitted 6-7 years ago. And it finally became a project. That's how to essentially define a set of cracking information so that it can be used for network level survey and also for future technology and automation. Here are the objectives of this particular project. Essentially, the first one is to develop cracking definitions for both asphalt and concrete. The second is help service providers and the DOTs to have objective cracking measurements. The new definitions would actually fit into continuing technological innovations. The third is to facilitate comparable measurement and interpretation of cracking. As we know that every state has different practices of how to collect and interpret cracking information. I'm going to show you some of the data we did on the survey. Number 4 is to have sufficient details to meet requirements so that automated methods are compatible with existing and emerging technologies. Even though this task was primarily for network level surveys, but we think that it should meet some of the needs at the project level. So that's a kind of summary of the 5 objectives of the project. The first portion of the project was a survey of state highway agencies. We did this about 3 years ago. So we have cracking data collection, processing, and common issues as part 1, and cracking definitions of transverse, longitudinal, alligator, block, edge, durability, corner break, and other cracking data. Part 3 is real path definitions. We ask questions about that. And also, we all know that the AASHTO does have a current protocol called R85-18. We'd like to know how many agencies are actually using or implementing this protocol, and general comments. We actually received responses from 38 different DOTs, and which is actually very good, we believe. We do have a published report online, so I'm not going to go through all the survey results, but I'm going to just point out something I think important to understand or to know for the audience. Like in the part 4, we ask how many agencies are using AASHTO, the AASHTO protocol, R85-18. So we know that 25 of them have not implemented. Okay, Okay, so about 9 of them. So it's a small minority that actually are either experimenting or using the ASHTO protocol, and that really tells this community that there is actually serious problem regarding how to standardize on cracking protocols or definitions. So I'm not going to read the whole thing on this, but from 14 DOT responses, we have this level of details regarding ASHTO R1885-18. Some of general comments are interesting, and of course, 33 of them provided general comments, and some of them are the same or similar. For example, we have those 4 comments here: development of cracking certification standard or practice, similar to that of right quality. Okay, this is the number 1 interest. We know that the IRI has been used for several decades, and in recent couple of decades really became a de facto standard, not just in the US, worldwide. There's a tremendous interest at the state level and also at the federal level to have something similar to that. It's going to take a while, but we need to start from somewhere. And then second one is improved cracking detection accuracy, okay, particularly in concrete pavements. We know concrete folks would like to know hairline cracking is still very difficult to do even with 1 millimeter devices today. The third one was to provide a protocol that can keep up with technology. So that's definitely is one of the objectives of the project. And then lastly, you know, can we collect the cracking data and get the results out while data is being collected, like the RI devices today for longitudinal profiling? Okay, all those are very lofty goals, and I think some of them are addressed in this project. Role cracking in the survey, network level, project level, you know, those are very, very important. I believe state DOTs would like to have some kind of protocol standard that can meet both needs instead of just one. Cracking data, very, very important, as we know, particularly in this session, many people talked about that in a lot of detail. It is just very important for both network level and cracking level, and for payment management and for payment design for that matter, and also for federal reporting purposes. Cracking data for payment management, those cracking information are kind of important, as we can know that a lot of the, nearly all the surveyed states, they do use transverse, longitudinal, and alligator cracking information. Those are the surface types information, more detailed. Cracking data designed by DOT folks and HPMS. Asphalt is percent of total wheel pass area exhibiting visible fatigue type cracking. So wheel pass is a critical term here for JPCP, percent of slabs with transverse cracking, and CRCP, percent of the area exhibiting longitudinal cracking, punch outs, and patching. For example, MEPDG, today is the ASHTO ME design, has very specific and detailed requirements for cracking information, and we had little of this requirement in the 93 design guide. So this has been a big challenge for all the states that are implementing or using ME design. And we would like to use the new protocols to meet that requirements as well for the ME design. Of course, MAP 21, I'm not going to read the whole slide. MAP 21 has very specific cracking reporting requirement called cracking percent, which we're going to actually address directly in our proposed protocols. Essentially, we need to define some cracking protocols that can meet the needs of network level and project level and reporting, and also can actually be automated in a reasonable way. As we understand, the current LTPP distress manual and also the ASTM PCI are all excellent documents for people to use per payment engineering discipline. But again, how to actually apply them in an automated way for both project level and network level engineering, it has been a failure, to be honest. Very difficult to use them in a automated way. So we really have to come with a clean sheet to design something that not only useful to engineers, but also implementable in an automated environment. So here comes our proposed definitions. We essentially propose 3 levels: level 3, level 2, level 1. So level 3 is more like very general, very network level for technology verification and qualification. And then level 2, with level 3 data, level 2 addresses network level payment management. And then when we go to level 1, it can be used for project level for both management and design. So so level 3 is the very macro big picture, and level 2 is the intermediate level, and level 1 is the detailed level. And as we go from 3 to 1, the more detailed level is inclusive of the prior level. So which means level 2 has level 3 information, and level 1 has level 2 and level 3 information. Level 3 is very simple. It's very similar to what map 21 asks for, cracking percent. We call that level 3 as a cracking percent for extent. Okay, essentially, we define the pavement into a grid, as shown here, along with wheel path definition, and then put them all into grids. And then the percent of the grids containing cracking would be the value we are dealing with here. So it's a very simple concept. It's actually applied in by many agencies and in the States and also internationally. For example, it's very similar to what UK scanner is, which was defined about 20 years ago. The grid size matters. So it depends on the what grid size you define. The trend is a little bit different. So we have recommended a particular grid size in our report, but again, that grid size sensitivity study needs to be conducted in a later study. Level 2 cracking width for severity. So in addition to the 5 zones we have with the wheel path, the 2 wheel path, we have cracking width information in level 2. That would include severity information. And the level 1 has cracking positions and orientations, okay? And that can be used for project level, both for management and design as well. So the 3 levels, in a quick summary, is level 3 is essentially for extent, okay, percent. Level 2 is level 2 includes severity information, and level 1 has detailed cracking positions and orientation information. Level 1, for example, what are the applications for level 1? We can, in this particular slide, we're talking about asphalt here, and we can use for HPMS and map 21 reporting. We can use it for MEPDG, ME design, calibration. We can use for PMS, general PMS. And for concrete, we can do longitudinal cracking, transverse cracking, corner break, and other cracking and quantification procedure is as presented on the slide. And we do have 3 severity levels as well. JPCP, JRCP applications are very similar to what we presented for asphalt. Again, for CRCP, level 1, again. Now, people would ask what are the differences between AASHTO R85 and the proposed definitions. Here are the similarities. We do propose to include crack orientation, crack width, and crack length. All right, and those informations are there. Wheel path definition is also there. Both protocols have a wheel path definition, and minimum crack length is a 12-inch or about a third of a meter, and that's the same. And then the angles between crack and length center line to define a longitudinal cracking and transverse cracking, and all this information here are similar. Deviations, of course, we are doing 3 levels cracking instead of just straight out 1 level definitions for everything. Image area outside and under lane markings is excluded. So we do not consider anything lane markings and outside of lane markings. We would propose wheel pass crack and sealed crack, which are not in the AASHTO. We would like to consider crack severity levels based on width. And we also propose definitions for concrete pavements, cracking definitions for concrete pavements here. I'm going to show you quickly. I don't think we have enough time. This project from from NCHRP is relatively small, so it's about $250,000. We spent a lot of time doing surveys, and then after the definitions are accepted by the panel, we went ahead and did a field trial. So 12 selected sites, about 2/10 of a mile for each site, and we did 5 runs for each site. So we did a total of 60 data collections in all, and we used the protocols to essentially compile the cracking data and see how easy it is. Again, we used the deep learning based CrackNet, a software tool that has been in production and used by many agencies. Here's the lane marking detection, and of course, wheel pass and grid generation. From this to wheel pass and grid. And from there, we started doing the summaries. As you can see, I'm not going to go into details. The trend lines are very clear when we do the repetitive driving, and we got pretty consistent results. So this is the level 2 cracking data and the level 1 cracking data. So from level 3 to level 2 to level 1, we are coming to a lot of information regarding cracking. For any of you who have any questions regarding this, please contact me at the university email address. I believe it's at the first slide. I really would like to hear from the audience to see how many people actually would like to get involved in the next stage of the research. Okay, so we did accomplish the 5 tasks for the project. And level 3 addresses cracking extent at the network level. Level 2 contains crack information with the severity levels or severity details. And level 1 is really further detailed regarding types of cracking on wheel path. I hope this is the last slide, or the close to the last. We are proposing NCHRP to start a new project, hopefully with more time and more funds. Essentially to do a design experiments to conduct data collection and define what ground truth cracking is, and develop a process to obtain the ground truth results. And then for the 3 levels of definitions, we do the ground truth analysis with the 3 levels. And then we would like to essentially working with 3 states or more to do demonstrations on how a truly automated system can collect and process in the network level data to satisfy the needs of both design and management at project level, and also, of course, at network level for payment management. So we hope that the follow-up project, if it does come, I believe it will, is to develop a draft AASHTO protocol. So for the AASHTO committee for consideration as either as a replacement or a complement to the current R85. So that concludes my presentation. Thank you very much.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.